Okay, so I'm not gonna lie. This problem sucks. Well, it's not terrible. It's just that you have to do a bunch of work to figure out what happens when you mix the first two and then mix 1 and 3, right? So I've got three liquids. One is 10 degrees, one's 20 degrees, one's 30 degrees, right? And they're equal masses, so that makes it a little bit easier. If I mix the first two liquids, the equilibrium temperature is 17, right? So 10 and 20 gives me 17. And then I mix the second and third, so 30 plus 20 gives me 28, right? Which makes sense. So that temperature falls between those two, right? Because some heat's going to get transferred from one to the other. And the question is, find the equilibrium temperature when equal masses of first and third are mixed. So this doesn't say water, this says liquids. So I don't know the specific heat of the liquids, so I've got to figure them out. So what I'm going to do is I'm going to write what happens when I mix 1 and 2. I'm going to do that first. I'm going to do 1 and 2, write what happens, then do 1 and 3, 2 and 3, and then combine them. Okay, so when I mix 1 and 2, MC delta T, M1 C1 delta T1 equals M2 C2 delta T2, right? Okay, so that means if I want C, let's solve for C2. Let's get everything in terms of C1. Okay, so C2 is equal to M1 C1 delta T1 over M2 delta T2. Okay, and equal masses, right? So that cancels out. So C2 is equal to C1, right? C2 equals C1 delta T1 over delta T2. Okay, so for my numbers, it's going to be basically T1 over T2, so that's delta T1. So delta, let me write this down so I know. Delta T1, delta T2, delta T3. Okay, delta T1 goes from 10 to 17, right? So delta T1 is going to be, I don't know why I put that. T1 is going to be 7 because it goes from 10 to 17. And T2 is going to be 20 to 17, that's 3. So this is going to equal C1 times 7 over 3. So that means C2 equals 7/3 C1. Okay, so I've got that. Okay, so now let's do the same thing. Let's mix 2 and 3, right? We mix 2 and 3. M2 C2 delta T2. The heat lost, or the heat gained by 2 equals M3C3 delta T3. The heat lost by 3 equals the heat gained by 2. Okay, so same thing. Let's do delta T2 and delta T3. Delta T2 goes from 20 to 28, so that's 8 degrees. Delta T3 goes from 30 to 28, so that's 2 degrees. That's the change. Okay, so same process. Let's solve for C3 in terms of C1. So if I take this equation, I'm going to solve for C3. So C3 equals M2C2 delta T2 over M3 delta T3. And again, equal masses, so that goes away. So C3 is equal to C2 times delta T2, which is 8, divided by delta T3, which is 2. 8 divided by 2 is 4, so that's equal to 4 C2. And I know, right, so from here, I know that C2 is 7/3 C1. So I'm going to say C3 equals 4 times C2, which is 7/3 C1. So that's 28/3 C1, right? Equals C3. Yeah, and does that simplify? 7, 14, 21, 28, yes. So that's 28 over 3, that's 7, right? So 3, 7, 14, no, that's 4. 7 times 4 is 28, right? So now that doesn't work. What, 28? 7 times 4. It does, yeah, that doesn't, well, maybe I'm just not thinking of it. I'm just going to leave it like that because it doesn't matter. Simplified or not. Okay, so now I've got two things that say C1, right? And that's going to make it easy because now, well, not easy, but now I've got to go write an equation for when I mix 1 and 3. Right, so I'm going to mix 1 and 3 now. So let's do the same thing. I'm just going to do all the algebra and then explain it. Okay, so here's my equation, right? So I change delta T1 into final minus initial, right? And then this one initial minus final to make the negative signs work out. And then I distribute in the MC, right? So MC times T final minus MT minus T initial, right? Both sides I've distributed this in. And then what I did was I combined the TFs. So this TF over here, where is it? That one. That's being subtracted, so I added it to the other side. And then this number, T initial 1, was being subtracted here, so I added this to the other side. So now my TFs are on the same side, my final temperatures. And so then I did the opposite of distribution, right? Whatever that's called when I like reverse distribute it back. So final temperature equals M1C1 plus M2C2, right? And then this divided by M1C1 plus M3C3, right? Not 2, 3. That gives you my final temperature. Okay, so now I've got final temperature. So that's equal to, I canceled out all the masses, right? Because it's all the same mass. It's equal to C3 times the initial of 3 plus C1 times the initial of 1 over C1 plus C3. But I already know that C1 is equal to, or 28 over 3 C1 is equal to C3, right? I figured that out already. So I can just plug that in here. So it's basically whatever you get here, 28, mine was 28 thirds, right? So whatever you get for this times your initial of 3. So my initial for 3 was 30 degrees, so I would plug 30 in, right? So if I was plugging my numbers in, I would put 30 here because that's initial of 3. My initial of 1 was 10. And then I would just solve this equation, and that would give me my final temperature, right? And the C1 canceled out because C1 is on the top and the bottom in both of them, right? When I add, so it ends up just being this. So like it ends up being kind of simple, but you have to, it's 3 steps. You have to mix C1 and 1 and 2 first to find C2 in terms of C1. And then you mix 2 and 3. And this is the thing you're after to solve this. So this is the one you need. So you have to solve for C3 and then get it in terms of C1. And then you can come over here and you can take this equation, once you simplify it, you can solve by plugging in your temperatures for 3 and 1 and use your C3 from over here in terms of C1, just the fraction that you got or the decimal that you got, right? So a little complicated, but if you write everything out and do it piece by piece, you can get it done.